Hello everyone, this is Victoria Muñoz de Iglesias from the Centro de Astrobiología, Spain. I've been studying icy moons for several years, mainly Europa and Titan. Today my intention is to explain, in an informal way, the meson cycle on Titan, one of the Saturn moons more important for astrobiology. Today we're going to be a molecule of methane, which consists in a carbon bonded to 4 hydrogens. This molecule was found first at the solar nebula and finally it finished forming part of the meson cycle on Titan. But before starting our trip, let me tell you a little bit about Titan. It is the largest satellite of Saturn, which is far from the Sun at 10 astronomical units. It is almost twice the Earth's moon. It is tidally locked in synchronous rotation with Saturn with an orbital length of 15 days and 22 hours. It is the only moon of the solar system with a hazy atmosphere, composed mainly by nitrogen, with methane and ice clouds, and a thick organic smog. The surface environmental conditions are 94 Kelvin and 1.45 atmospheres in average. The icy crust, mainly composed by water ice, has organic deposits, liquid hydrocarbon lakes, and cryovolcanic features. Titan could be formed as material in orbit around when an early Saturn began to accrete. Thus, we begin our trip from the Sun, flying through the planetary disk. At one point, we're going to note a slight force which attracts us, and it makes that we turn slightly our course. We are entering the gravitational field of a Saturn that is still forming. In our trip, the temperature is decreasing gradually. There's going to come a time in which it is so cold that ices and clathrates start to form at our surroundings, and at the end we finish joining to one of them. With the time, we'll see that more and bigger fragments, already called planetesimals to their size, collide around us. Before we realize, we'll be at the interior of a primary Titan, still not differentiated in layers. Titan started to differentiate in accordance with the density of the materials that were condensing in a rocky current mantle, a high-density water ice layer, a liquid water ocean, and an icy crust of normal ice and clathrates. We, as good methanes that we are, will be at the two upper layers, dissolved in the ocean or within the clathrates of the crust. Even, as we're going to see, we can travel from one to another depending on the thermal evolution and the mobility of the crust. Now that we already are at the interior of a more differentiated Titan, we start our hydrological cycle that, as I'm showing here, it seems that it can be similar to the cycle of water of that planet closer to the Sun known as Earth. But maybe not just the methanes which come from outside are dissolved in the ocean. Perhaps we meet new friends, younger than us, that were formed in their own Titan through serpentinization processes and or that they come from organic synthesis from methanogenic archaea. During Titan's evolution, the appearance of hot plumes can promote, if I'm dissolved at the ocean, that I absorb and rise up to the crust as a bubble, where I can enter a clathrate. Furthermore, if this plume reaches also the crust, it will destabilize the clathrate where I'm inside, and I'll be again a precast molecule, able to continue its path up to the surface. If, before reaching the surface, I'm in an aqueous solution very viscous, surrounded by salts and ammonia, the eruption will be effusive. However, if at my surroundings I just see water molecules, the solution will be slightly viscous and will be able to get outside in a more explosive form. Once at the surface, we can find two scenarios: an icy crust kind of clean, or that just match, that we go out where there is a lake with other hydrocarbons in nitriles. Similar to the cycle of water in Earth, from what others have told us, these lakes can suffer evaporation occasionally in warmer periods. If it's hot enough to evaporate us, we'll be able to fly up to the atmosphere as a gas form. If we stay at low altitudes and the temperature decreases, we can get together with other molecules and form clouds. But if we get in rising, we'll receive the impact of solar high-charged particles. We'll lose a hydrogen and form the methyl radical, with additional electrons that cause that we interact with everything what we find. Here, the photochemical path of the methyl that lost its hydrogen by photolysis. This reaction of methyl radicals form ethane. Reactions of other radical species with atmospheric molecules, including nitrogen and hydrogen, followed by photolysis and subsequent reactions of stable heavier hydrocarbons, result in the formation of more and more complex hydrocarbons and nitril species. Then these species condense in polycyclic aromatic hydrocarbons and polyacetylene and nitrile polymers, all leading to the production of a haze. And now we go back down. At the clouds, if we keep getting together with more molecules and the temperature continues decreasing, we'll get close enough to transform from aerosol to liquid state, and we'll back to the surface in the form of rain. This is what we'll see in our free fall. Hopefully, we'll fall in an existing lake that cushioned the blow, or in a clean zone in which with other cloud pillows we can form a new lake. Once at the surface, if it's porous enough or it's fractured, perhaps over time we can percolate or diffuse through the crust of rising classes, as you can see at the right of this scheme. In our descent, we can travel from a cold and brittle crust to a warmer and more ductile layer. Maybe, in our way through the crust to the interior, we fall within a clathric cavity, where we'll stay there in the shelter while the environmental conditions, the pressure temperature conditions allow it. Or even by crust movements exists the possibility to expand the cycle to greater depths and rather to the ocean of liquid water where we'll dissolve again. Hope you enjoy the trip. Here we'll stay at the ocean, diving until the next hot plume which pushes us outwards. Just to say that this presentation could be done thanks to the data collected during the successful Cassini-Huygens mission, which lasted almost 20 years, and that some of the processes mentioned here are subject to debate nowadays. Thanks for the company.